Okay, in this problem, you are asked to find the predominant species of citric acid buffer at pH 4. Citric acid buffer is a polyprotic acid, polyprotic weak acid, and it has actually 3 ionizable groups. They're all carboxylic acids. And if you look on the structure, the fully protonated structure, you can see the carboxylic acids here, here, and here. This is the fully protonated structure for citric acid, and citrate is represented here, and you see all of those groups have lost their proton and have a negative carboxylate. And when you are trying to figure out the predominant protonated state of a buffer, the way I always do it is I start out with the fully protonated species. This is the species that will exist at low pH. Then what I do is I list all of the pKa's from smallest to largest number. So our first pKa, which is given, is 3.13. The next one is 4.76, and then the final one is 6.4. Now, every time the pH goes up, there is a corresponding drop in the concentration of H+. And when H+ becomes scarce, it leaves the weak acid. So as H3A goes up from a pH below 3, where this is the predominant species, a proton will leave. When H+ leaves, we have 2 H's and a negative charge left behind, and so the species becomes H2A1-. As the pH continues to increase, protons leave every time the pH reaches a pKa. So at pH 4.76, another H+ leaves, and the subsequent species is HA2-. And then finally, as it goes through the third pKa, you have A3-. Now remember, at pH equal to the pKa, you have 50-50 of each species. So at pH 3.13, the concentration of H3A is equal to the concentration of H2A-. At a pH of 4.76, the concentration of H2A- is equal to the concentration of HA2-. Likewise, at a pH of 6.4, there's going to be equal amounts of this species and the A3-. So our question says, what is the major species at pH 4? Well, pH 4 is in between 3.13 and 4.76. So that means that our citric acid buffer will have lost 1 proton. So I'm not going to worry so much about which carboxylic acid, because I didn't give you that information, loses a proton, but basically the structure will be H2A1-, and it will have 1 carboxylate, and the other 2 carboxylic acids will remain in the protonated state. So this is our answer.